Hi, I'm John Rohit Ernest, and today I will do a walkthrough of my code as to how to build a content based recommendation system as put out in the README script. And I will also explain how to run the code as well. So I will start the process. So I will share my screen. Okay, so first of all, this is my GitHub forked repository. So over here, you can see the CSV file and there is a Jupyter Notebook file. So as I mentioned in the README script, the data set was taken from Kaggle. So it is called Wikipedia Movie Plots data set. So since it was a very huge data set, for simplicity purpose, I've randomly selected 500 movies to create a small data set. So over here, you can see the data set. This is the yeah, this is the data set, and over here there are several columns. For example, release, year, title, origin, director, cast, genre, wiki, page, and plot. So for our purpose, I have selected only origin and plot, which we require for the recommendation system. So I will, so over here to run the code, to run the entire process. So first we will click this Jupyter Notebook file. So it was created using Colab. And over here, there is a button you can see to open in Colab and you can press it. So it will directly take you to a Colab file. And over here, if you see, there is a text importing repository. So if you run this first piece of code, all the files that are in our repo will be directly imported here. So we have the data set in our repo, so it will be imported directly here. So I'm running the code. So you can see over here. Yeah. So if you see over here, all our contents in the repository have been imported here into this Colab directory. So then we import the dependencies, we import pandas, numpy, and we import sklearn extraction.txt for vectorizing the text, and we use several pre-processing things, and we also have to measure cosine similarity. So we import that as well. And over here, I'm loading the data set. I'm using the path from over here and I'm displaying the first five rows as you see title, origin, cast, genre, plot. So it is written everything in a beautiful manner. And then I'm checking whether there are any null values. There are no null values. There are two null values in the cast column, but it is irrelevant because we need only the title and the plot column. So these are our columns. So the observation, as I mentioned, so the title and plot columns are stored as object data types, and there are no null values in a data set for key columns. So then this is our text vectorization. This is our process of vectorizing the text, and then for better pre-processing, as a better pre-processing technique, I'm doing. Uh, Yeah, as a better pre-processing technique, I'm reducing the dimensionality of the matrix. And then over here, we return the vectorizer and we return the matrix, sparse matrix. So we reduce the dimensionality using singular value decomposition. And then we process the query. So we transform everything. We convert the query into TF-IDF representation, and we then apply SDF transformation, and then we do the normalization stuff as well. So then over here, you can see we are computing the similarity and recommendation retrieval. So over here, the cosine similarity function is defined here, and then we are returning the title and similarity score of the items that are being recommended. So uh, so over here, I'm running the pipeline again, and then I'm displaying the results. So if you see over here, the top five, so the script over here, I've selected the exact script that was in the README script defined by the firm. So the user query is I love thrilling action movie set in space with a comedic twist. So these are my results with the title, the top five results, the top five recommendations, and the similarity score is as well mentioned here. So this is how the result is being displayed. So it's very easy to run and over here, if you see, uh, it can be done, it can be ran directly on a Jupyter notebook file as well, but you have to make sure we have to make sure I think running in Colab is simple, but I think with this piece of code, even if you run it on Anaconda or any other Jupyter notebook platform, I think with this script, I think it's possible to import all the scripts, all the files, I mean the data set that is in our GitHub repository. So I'm very thankful to Luma for giving me this wonderful chance of writing this code and walking through the demo. It was very wonderful. Uh, uh, it was very wonderful experience for me to do a hands-on experience on content-based recommendation systems. So I'm very thankful to you and grateful to you for this terrific opportunity.